So today we are looking at two-step equations. We've been working with two-step equations for a significant portion of this section already. So today in many steps is going to be review. We will put some more words to it and give a little bit of more direction than we've had in the past. But overall it's just a pretty straightforward review of stuff we've already been doing on some of our problems so far. So today is 1.2D two-step equations. And this one is actually straight out of the book, although we've been developing skills that we need to use in many of these problems, the distribution, the collecting like terms already. So, like with solving one-step equations we did before, or simple equations is how they were called, our goal is to get the variable by itself. And this is represented by it looking something like x equals, if you're solving for y, it might be y equals at the end, maybe z equals, but it's all pretty much just the variable equal to a number. Now the steps that we use, essentially speaking, is PEMDAS backwards. Now, this doesn't take into account using the distribution and the collecting like terms that we had before. So like in yesterday's notes 1.2c, you will want to distribute and combine like terms before you go ahead and do this part backwards. But that's essentially what it is after you do the distribution and combining like terms. Occasionally, not frequently, but occasionally we might end up not following this rule exactly. So this is more of a suggestion than a hard and fast rule. And over time we'll start to see more examples where that might be the case. In general, what we're going to want to do is start with the number farthest away from the variable. And I'm in desperate need of a new pen. So give me a moment while I swap them out. So we generally want to start with whatever is farthest away from our variable. And whatever's farthest away is typically being added or subtracted to the variable term rather than what is being multiplied or divided by it. So let's look at a handful of examples. We're going to have a total of 5 examples to look at today. And we're going to begin with examples where we're going to have to do some division at the end. And these I feel like are the more conventional examples. So for A, we have 5 plus 4k equals negative 39. And in order to solve this, we need to do the thing that's furthest away from our 4k. Essentially, we need to isolate 4k first and then solve for k. And in order to isolate our 4k, we need to get rid of our 5. So we subtract 5 from both sides. Since both negative 39 and negative 5 are negative, they combine to make negative 44. You divide by the 4 and end up with k equals a negative 11. So it's just a quick 2 steps. You just got to know what the correct steps are to do. And remember, we're using our inverse operations, which I've been drilling over and over and over again. Since this is positive, we subtract it. Since this one is multiplied by k, we divide it. Likewise, if we look at B, B is just like A in this first example. So we have 4 minus 6x equals 34. And solving it takes exactly the same steps. We have this positive 4 sitting out here, and in order to get rid of it, we need to add it to we need to subtract it to the other side. Because this is positive 4, our opposite is subtraction. So, what we end up with is negative 6x. That's still over here. These 4's cancel out. We have 34 minus 4, which is 30. Then, since this is a negative 6 times an x, we divide both sides by negative 6. And we end up with x equals a negative 5. Feel free to stop the video whenever you feel like you would like to spend the time attempting these problems before I do them. So we're going to move on to example 2, which I'm going to do in purple because my black pens are running out of ink. And we're going to begin with A. A is going to feature some division this time. So this one is negative 10 plus n divided by 2 equals negative 15. Now, once again, this is our variable term, and we want to get this alone, so we need to get rid of our negative 10 first. Since it's negative, the opposite of the negative is adding, so we're going to add 10 to both sides. Our negative 10 and positive 10 cancel out. We're left with n divided by 2 equals negative 5 plus 10. That leaves us with a negative 5. Now, this fraction, n over 2, what it means is that we're dividing n by 2. And since we're doing a division here, we need to do our opposite operation of that, which is multiply. So we multiply both sides by 2. The 2's on this side go away. We have n times negative 5. N equals negative 5 times 2. A negative times positive negative. 5 times 2 is 10. All right, B. Let me write it down. You might take a moment to try and solve it on your own before I go through it with you by pausing the video. We have x over 14 minus 6 equals negative 7. So, once again, we are subtracting 6 here, and in order to undo a subtraction, we need to add the 6 to both sides. That leaves us with x over 14 is equal to negative 7 plus 6. The difference between them is 1. Since the negative 7 was bigger, it is a negative 1. Since this is x divided by 14, we then multiply both sides by 14. These cancel, and we're left with x equals negative 14. Hopefully this will be pretty straightforward, although we're going to throw one more example at you, and this one is going to be trickier, and this will go back to the old implied parentheses thing that we saw earlier. This is example A. There's only one example on this one. This one is h plus 3 divided by 4 equals 2. Now you might be tempted here to say, well, we have plus 3. This is just like example 1 where we need to subtract at the beginning. However, that is not the case. And the reason is because if we look at this carefully, this clearly looks like h plus 3. The entire thing is being divided by 4. And this is where we have those implied parentheses. I'll put the implied parentheses in green, so hopefully this will be slightly more clear. This is where we have implied parentheses that come into effect. So normally, we would want to do an addition and subtraction here. But because this is trapped inside the parentheses, we need to get rid of this divide by 4 first. And we remove the divide by 4, as we did in the previous two problems, by multiplying by a 4. So I'm going to multiply both sides by the 4. Those 4's will cancel. And then we will be left with the top of our fraction, which is h plus 3, and it equals 8. And from here, this is a pretty easy one-step equation. We have plus 3. We've got to do our inverse or our opposite operation, so we subtract it. H is 5. Now, if you want a little bit of an additional challenge, the other thing you can do is you can take all these numbers that I've plugged in, that I've solved for here, these 5, you can try plugging them into the original equation, replacing the variable with those numbers, and then you'll find that all of these statements will end up equaling whatever was on the right side of the equal sign at the beginning. To check your work. This is something that you can always do on these problems, and it's a very good idea on, say, a test to make sure that you get full credit.